All right, so the first one we're going to focus on is the mean. And we're going to focus on the mean because it is the most commonly used measure of central tendency. Remember, central tendency is just another name for average. So it's the most commonly used measure of central tendency, and it is the arithmetic average for a group of numbers. So in other words, this is called an arithmetic average. So is this. So these are both formulas, and we're going to learn which one represents the sample and which one represents the population. But you should already know, oops, this is missing the bar on top. Well, it'll appear in a second. But just remember there's a bar here. X bar is an English letter. Mu is a parameter. So can you tell me which mean comes from the sample and which one from the population? This one comes from the sample, and this one, population. Why? Because the Greek letter was the giveaway. This Greek letter means that it's a parameter, which means it was calculated on the entire population. And the way we pronounce it is mu. Okay, this is how we pronounce this symbol, mu. X bar, well, the X is an English letter, and you have to just recognize that that's just a line. But X bar is considered an English letter, so it's the mean of the sample. So what this is telling you is add up this line here, which looks like an M that's been pushed over on its side, right? Looks like an M. That has a name. It's called sigma. Just like, you know, when we had the symbol for standard deviation and variance, it was kind of like a circle, right? A circle with a line on top. That was sigma as well. This has the same name, but it means something different. This sigma means add up. Add up all your scores, all your X's, and then divide by however many scores you have in your data set, in your sample. Now, you might think that's very frustrating. How dare statisticians call something like this the same name as sigma, the circle with the line on top, for standard deviation, or sigma squared for variance? Well, we really have no right to criticize statisticians for doing this because we see this all the time in the English language, right? I can talk about a sale. Now, what am I talking about? Am I talking about the sale on a ship or the sale that's going on right now at TJ Maxx? You see how things can sound the same but mean something very different depending on the context. So here, we just have to realize that when we talk about sigma, we need to look at the context. Are we talking about an average, or are we talking about variance or standard deviation? Variance and standard deviation refer to variability, not averages. We'll learn about that in the next chapter. All right, but so if you see it, sigma, in this context, you know it just means add up all your scores. So X bar, mean of the sample, you take all the scores in your sample. Oh, that's my 5-minute warning here. Take all the scores in your sample and divide by the sample size, the number of scores. The mean of the population would be adding up all the scores in your population and dividing by the population size, which is by convention represented by a capital N. This is a lowercase, obviously. So if you had 100,000 people in your population and you tested all 100,000 people, then the N is 100,000. So you would add up all the scores in the population and divide by 100,000 the number of scores. Now, I'll just end on this. I want to make sure everybody understands that you should never look at the size of a data set to determine whether it came from a population or a sample. Some samples are very small, 5, 6 people in them. Other samples could have hundreds of thousands of people in them, or dogs, cats, chairs, whatever it is you're studying. All right. So samples can be big or small. Same thing with populations. Populations can be ginormous, like, for example, the population of insects on planet Earth. I don't even know how you'd go about estimating that, but it is, what would Dr. Evil say? It's a cajillion, billion, trillion, mazillion. That's how big it is. All right. So populations can be very, very large, or they can be really, really small. If we defined a population very, very narrowly, we can get it down to maybe, a couple dozen, or even, 10 or whatever. So never use the size of a data set to determine whether it's from a population or a sample. You would have to be told, is it a sample or a population? You have to have that information actually spelled out for you, or in the very least, you could look at the symbol. Did they use a Greek letter for a parameter and a population, or an English letter for a sample and an estimate? Remember, these are estimates if they're calculated on samples. And that is as far as we're going to go right now into Chapter 3. So stay tuned. The rest of Chapter 3 is coming up very soon.